Hi. This experiment is regarding part of the hardware schemes for smarter indoor robotics to prevent backlash framework using FPGA-based multi-robots. This experiment is regarding of a dynamic when the multi-robots are moving in a backing away from its environment. At that time, how it the challenge in a dynamic scenario. So in that scenario, how it looks over. Let comes to the point here. Just now in the previous experiment we mentioned about the static in this experiment, when it is not in a static mode, when it is just towards a dynamic, then how the robots will understand the environment. So they first consider themselves as a first come first serve schedule method. Mean any robot can come at a time out, but without colliding with others, they have to take up their own scenario. Either there may be a front line, there may be a middle line, or there may be the end of the scenario. So anyway, the situation of them is going to present, so that it's calling as a first person. At the same time, when they having of a that numbering means that when there the position was a confined, yes, my number was in a 1 2 or 3 4 wherever it may be. So among that, yes, now the to avoid that scenario, we came out with the integrity of the adaptive cruise control mechanism. So the behavioral between the four robots, which is that we are having of a adaptive cruise control, is going to include it. By that, we are going to achieve the backing crash prevention. That was our approach. Among this, which we are mentioning that we are using of a the just now mentioned as a first come first serve method and adaptive cruise control mechanism. Let if we observe here we are having of a novelty is a partial reconfiguration. When comparing towards the general flow, the device utilization was very high. So it was the LUTs are around of 82% and the block RAMs were 77% and also the DSP size slices was 64%. If we take in and around of our all the partial reconfiguration technique, when we are prefer this technique, so by that we are going to have the consumption was a very less comparatively the overall implementation method. How it works over on the runtime dynamically based on the situation, partially configuration, a control decision will take the decision and execute of that particular module. So that was the beauty of this particular design. So let comes towards the point of the discussion of the experiment which we conducted over. Right now in this experiment, we are representing about the dynamic scenario. In the dynamic scenario, yes, now if you observe all the four robots without their intention, they come out with respect of their requirements. Now in this scenario, the robot, R3 robot is came out and it is taken off its first choice and it went into the path. So that now means it mean by it in the scenario it was there. And immediately the R4 is there and also the parallelly R1 also there. But R4 is not having of a chance, even it came out, but because the reason R1 is before it. So by using of adaptive cruise control mechanism, which we are mentioning here, as R4 is awaited, and once the R1 is left over, then only the R4 was started off as a navigation, right? And the ultimately the R2 is not having a no choice because they're totally blocked by the robots. It's waited for a stop and go method of whatever we said as the adaptive cruise control method. Then it is executed of that option. Now all the robots, as per their next level of application, they are executed of this particular one. So the novelty of in this particular one, communication between the four robots is happened by using of a Wi-Fi module and so on, and their angles, everything is calculated by using of digital compass, and also the internally we are going to use a codec and so on. Yes, thank you very much. Thank you everyone.